Okay, so this is Unit 5, FRQ Part B, number 1. So let me write that down. So FRQ Part B, and this is number 1. So it says no calculator is allowed for this question, which means any little mathematical anything that you have to do is going to be done by hand. No scientific calculator, no nothing. So they give us this graph of G. Here's a graph of G right here. Like it's going up. This looks like it's kind of concave up. It's increasing. It switches right here. It's concave down. It's still increasing. It's got a y-intercept. It's all completely above the x-axis. We've got lots going on here. So this is a graph of G. It says that it's a continuous function. They show it between -3 and +3. They tell us that G is twice differentiable except at x equals 0. So when you look at this right here, this is an inflection point, and that means that the second derivative does not exist there. All right, so we'll get into more details with that. They give us this information. They say that f is this info, so I'm gonna write this down. So f of 0 is equal to -1, we know that. And then it gives us this derivative, which is how we're gonna relate back to that graph that we have eventually. So f prime of x is equal to, we've got this little binomial, x squared minus 5/4, and then multiplied by e to the x. So right now they give us some info about f, they give us a graph for g, they're going to be tying both of these equations in here. Part A is about f, part B is about f, part C is about g, and then part D ties together f and g. So we're going to be using a little bit of both. So letter A. Letter A says find the x coordinate of each critical point of f. Okay, so we want to find the critical points of f. So remember what that means is that is where f prime is either equal to 0 or undefined. Okay, so we want to take f prime and set it equal to 0 or where it is undefined. That is what we're looking for. Undefined really only happens when you have a denominator, so we're not too worried about that here, but we do want to set it equal to 0. So we're going to take this x squared minus 5/4 multiplied by e to the x, and we're going to set that equal to 0. This is kind of like you're looking at two separate factors, so you're going to set each one equal to 0. So set this equal to 0 first, set this equal to 0 second. We're not worried about it being undefined. So here we would add the 5/4 to both sides, take the square root. Square root, we always start with a plus or minus, and then we have root 5 divided by 2. This right here, technically the way that you would solve this is by taking the natural log of both sides. So you take the natural log of both sides, and then you have x is equal to the natural log of 0, which does not exist. 0 is outside of the domain of this natural log function. So this does not give you any solutions. E to the x will never equal 0. No matter what exponent you plug in here, an exponential function is always positive. So this doesn't give you any solutions, but we do have two critical points right here. So when we keep reading part A, it says classify each critical point as the location of a relative minimum, a relative maximum, or neither. So here we haven't really needed to bring the second derivative into things, so we're just going to do the first derivative test. So the first derivative test works like this. You make a sign chart. You label it f prime, because you are interested in values of f prime here, and label your critical points in numerical order. Okay, so now what we're trying to figure out, we are classifying points as either maximum or minimum points, and so we're looking for a sign change on f prime. If f prime changes positive to negative, that's a max. If f prime changes negative to positive, that's a min. So that's why we're setting up the sign chart, and that's why we're using values of f prime. So super important to note that this guy is always positive. Always positive no matter what. So let's plug in some values over here. And if you're like, I don't know what this is equal to, you can be really dramatic. You can be pretty sure that it's smaller than like 100, right? So we could plug -100 in here. So if we plug in -100, we get 10,000 minus 5/4, and you can be pretty confident that that's a positive value. You're multiplying by something positive, so it comes out positive. In the middle here, 0 is definitely in between these two numbers. So 0 squared minus 5/4, that's negative. This is positive no matter what. So this will be negative. And then bigger, again, you can be super dramatic and say like 1,000 is definitely bigger than this number. So if I square that minus 5/4, that comes out positive. This is positive, so this is positive. We also talked about how if you just know the pattern of this quadratic, it's a parabola that opens up like this, right? So it goes positive, negative, positive, and you can use that for the sign chart. So this critical point right here our first derivative changes from positive to negative, which means our graph is increasing and then switches to decreasing. So that makes this a maximum. So this is a maximum. And then here our first derivative is negative and then positive, so our graph would be decreasing and then increasing. So that makes this one a minimum. And letter A did say to justify your answers. So you're going to say that this is a maximum because f prime switches from positive to negative there. And then this one is a minimum because opposite, f prime switches from negative to positive there. So that's how you would justify an answer. All right, so that was letter A. Letter B says find all values of x at which the graph of f has a point of inflection. Give reasons for your answers. Okay, so remember we don't have a calculator, so let's look at our handy little chart. F has a point of inflection when f prime has a max or min. Okay, so f prime, just looking at the equation for f prime, we're not gonna know where it has a max or min. So we actually need to take it one step further to f double prime. So we're gonna find f double prime and then make a little sign chart, see where it has a sign change. All right, so we know that f prime is this equation right here. So we need to find the second derivative. This is a product, so we're gonna have to use a product rule. So we do u, which is just the original, times v prime, which is the derivative of e to the x, still e to the x, plus v, which is this, times u prime, the derivative of x squared minus 5/4, which is just 2x. So that's my product rule. I need to know where that's equal to 0 so I can figure out where it has sign changes. All right, so I'm going to set this equal to 0. First thing I want to do is factor out an e to the x. And when I factor out that e to the x, I am left with this, right? So we want to set that equal to 0. We know that this is never going to equal 0. So we can take this quadratic and we can set that equal to 0. All right, so this, let me play around with this for a second. I don't love having this fraction here, so I'm going to multiply everything by 4, see if that helps. Okay, so multiply everything by 4. Now let's see if this is going to factor down. Let me play around with some numbers for a second here. Okay, so let's try 2x and 2x. Multiply into -5, so this would be like a +5 here and a -1 here. Yeah, that'll do it. So this, if you FOIL it out, you have 10x minus 2x, that's your 8x. So set that equal to 0. So set this equal to 0 and we get +1/2. Set this equal to 0 and we get -5/2. So those are where your second derivative is equal to 0. We call those potential inflection points. They might end up being inflection points, but you need to confirm that you actually see a sign change there. All right, so we're going to set up a sign chart for f double prime. We want to know the sign of f double prime this time to see if those signs are actually changing at these points. All right, so we're going to plug these values into the second derivative because we want to know if the second derivative is positive or negative. So remember, this guy is always positive, and you can do the test, or you can just recognize that this is going to be a right side up parabola, and just like this right side up parabola, the sign will go above, below, above, so plus, minus, plus. So we can just kind of know that this is how it's going to work out. If you don't believe me, if you don't like that method, you can just plug in some different test values. Like this is -2.5, so you could plug in -3. This is positive, so don't forget you have like this e to the x out front. So this is always positive. If you plug in -3, this is -7. And then if you plug in -3 here, this gives you a -1. So positive, negative, negative comes out positive. Then you could plug in 0. This is positive. This is negative. This is positive. So it comes out negative. And you could plug in like 1 or 2. This would be positive. This would be positive. This would be positive. So those are your sign changes. You can see that it does change sign here and it does change sign here. So when the question is, find all values at which the point of f has a point of inflection, we would say x equals 1/2 and -5/2 because F double prime changes sign. And we back that up with the sign chart that we just made. All right, so that's B. So now we're done with F for right now. Letter C is going to bring us back to our equation G that we have the graph of on that front page. So it gives us this table. So I'm just going to put the table right up here. Fill in the missing entries in the table to describe the behavior of G and G prime on this interval. Indicate positive or negative. Of course, I printed this double-sided, so I'm going to keep flipping back and forth between the graph and this chart right here. So we want to know what is happening for G prime on this interval. So between -3 and 0, we want to know the sign of G prime. Okay, so if you look at this graph, this is G. Here, we want to know G prime. So what we're looking at, if we want to know if the derivative is positive or negative, that means we want to know if the original is increasing or decreasing. So this graph is increasing, and then it keeps on increasing. It changes its concavity, but it's increasing the entire time. So it increases, keeps on increasing. So if we're looking at this table, our first derivative would be positive because the graph is increasing. And then in this next section, our derivative would still be positive because that graph is increasing. And you can see right here in between, they're saying that G prime is equal to 2. That means that right at this point, the slope is 2. And it's saying on the ends, the slope is 0, which makes sense. Slope of 0, slope of 0, slope of 2. So now they ask us about the second derivative. The sign of the second derivative tells us about the concavity of the original graph, or the bend. Okay, so if you look at this piece right here, the first section of the graph appears to be bending up, like a right side up parabola. So that is a concave up shape, which means the second derivative is positive. And then if you look between 0 and 3, that's this section of the graph right here, it switches its bend, and now it is bending downward, right? Facing down like an upside down parabola. Downward bend means concave down. Concave down means a negative second derivative. All right, so giving reasons for your answers. We're going to kind of justify these things right here. So I'm going to write next to this one. G prime is positive in both of these spots because G is increasing. And it's increasing everywhere, which means that G prime is always positive. Next, this one, G double prime is positive because G is concave up. And then this next piece, G double prime is negative, and that is because G is concave down. So kind of working backwards. Normally you'd say G is concave down because the second derivative is negative, but we're kind of working backward here. So that's what this table would look like. And last piece, part D, we've got a new function h that is defined as f times g, and we want to know if h is increasing or decreasing at x equals 0. So this is going to be D. So h is f times g. So when they ask a question like this, we want to know if h is increasing or decreasing. So if the original is increasing or decreasing, that means its derivative is either positive or negative, okay? So we want to know if h prime of 0 is positive or negative. That is the question that we are getting at here. So they say, is h increasing or decreasing at x equals 0? That means, is h prime positive or negative at x equals 0? So this is what we're trying to find. So we want to figure out what h prime is first, just like as an actual function. So that's going to require a product rule. That's a product right here. So we have u times v prime plus v times u prime. So that's the derivative using a product rule. Then they are interested in h prime of 0, so we're going to sub zeros into all of these pieces and then talk about how we can evaluate each one of them. And we're going to be using some tables, we're going to be using the chart, some slopes, different things. So f of 0, they actually give that to us way at the beginning of the problem. They tell us that f of 0 is equal to -1. So that is going to be subbed in right here. Then g prime of 0, we can look on the table or we can look on the graph. So g prime at 0 is 2. Plus g of 0, again, look right on this table, g of 0 is 2, or you could look on the graph for that one. And then f prime of 0, they don't explicitly give it to us, but they do give us the equation. So if we wanted to know f prime of 0, I would just plug a 0 in right here. So if I plug in 0 there, I get -5/4. And if I plug in 0 here, e to the 0 is 1. So that just gives me a negative 5/4. So now no calculator. So remember any silly little arithmetic you're doing in your head. So this ends up being a negative 2, and then plus this is a negative 10/4, which I can simplify. Negative 2 plus negative 5/2. So that's negative 2, negative 2.5. That would be negative 4.5, or you can do mixed fractions or improper fractions or whatever you want. All right, so that is free response B, number 1, and I'll do one final video for number 2.